Welcome to the Cannabis Equipment News Podcast.
Hi, I'm David Manti, and welcome to a new episode of the Cannabis Equipment News Podcast. With me this week is Harley Smith, who's been doing hydroponics research and education for the better part of 30 years and works with Harley Smith Hydroponics. Thank you very much for joining me today, Harley.
Pleasure to be here. Thanks for inviting me.
Before we get started, please make sure to like, share, and subscribe to the podcast. You could also help us out a lot by leaving the podcast a positive review on whatever platform you use. If you want to email the podcast, you can reach me at david@cannabisequipmentnews.com with email the podcast in the subject line. You could also subscribe to our daily newsletter. Make sure you get it delivered to your inbox first. Harley, I wanted to start not just with a little bit of background, but I wanted to say that this is maybe episode 140, and you are by far and away the most requested guest that I've had from other people reaching out.
Okay, that's good to know. They know I'm still out there. I'm retired now, but I'm still alive, still well, still teaching a little bit. So it's good to know
very
they're requested too.
Very happy that you're still alive and well. But I wanted to learn a little bit more about how it all started. How did you get involved with the cannabis industry?
Okay. Well, it was actually kind of coming through the back door. I wasn't just a grower that went bigger and bigger and then started doing education. Back in 1995, I was a video producer doing producing videos on science and technology. And I was contracted to produce a video on introduction to hydroponics, mostly for schools, for education. And of course, back then I knew very little. I did one little tinkering with hydroponics when I was in 7th grade, a little kit. But, I was totally a newbie. But by the time I did the interviews, did the research, wrote the scripts, produced the video, afterwards that turned into a series of videos. And then I was offered a position to work full-time with schools, introducing students and educators to the science of hydroponics. And I really got really interested in it. Back then it was huge. We were importing more hydroponically grown food than we were producing here in the United States. So I said, wow, there's a technology gap. What's going on? So I knew it was important for the future. And believe it or not, though, I didn't make the association with cannabis right away because I was brought in specifically to work with schools, talking about vegetable production, culinary herbs, and about the science. It didn't really occur to me. It's kind of funny how naive I was that it could be used to grow some really great cannabis too. But I was going to do one of my very first teacher shows for the state of Michigan, for the Science Teachers Association. And the owner of the store said, well, you're going to be getting some jokes. I said, well, what do you mean? Oh, growing cannabis, growing marijuana. Oh, yeah, I guess you really could, couldn't you? So that's where I started in cannabis. But I was working with schools. I was doing professional development workshops for agriculture teachers. I started working with growers through a hydroponics store, managing one in Detroit, one of the biggest ones in the area. And but I was always involved and interested in the science. The science of growing. What are the ingredients in the products that people are buying? How do they work, and why? So that led me into more and more interest in some of the things that were going on in Europe. It's led me into making some new discoveries, asking some new questions, and I got the white jacket. So even then, though, that was back in the days when cannabis was illegal. So I was showing people how to grow great plants, how to improve the nutritional value of food, how to improve the plant's natural resistance to pests and disease, how to also improve the flavonoids and the terpenes and some of the medicinal characteristics. And of course, it didn't take long, once we started getting just a little bit of legalization, that the followers came out of the woodwork. And Some of them were there the whole time. Let's put it that way. They just didn't tell me what they were growing. So that's kind of how I got interested. And then, of course, once it was legal, let's see if I can grow this. You know, I mean, I know what to do. Applied a little bit, PHEC, change the reservoir, get the right lighting, and lo and behold, very first time, hit a home run. So I said, okay, you can grow really great tomatoes with double the lycopene content and increased vitamin C, you can grow really good weed. And that was the beginning of the whole next phase of my career. That's a long answer.
No. I mean, I don't know that that's the long answer. That's the short answer. I want to know more about every step of that. What was it, when you're producing these videos, what was it about hydroponics in particular that kind of got your attention? Just because I figured you were probably producing videos on all different types of subjects.
I was. Well, yeah, I was doing a lot of different videos on science, even on lightning prediction systems, the use of the golf courses for the PGA, and a lot of stuff with robotics and CAD/CAM and some of the new technologies in CNC and those kinds of things. But it was new. What got me interested, though, my father is a biology teacher. High school biology teacher. I grew up in the lab. From the time I was little, when looking at picture books, I was looking at biology books, and looking at the pictures. So I was always interested in biology, but I didn't really think of plant science as being, I thought, well, that's farming. It's not, I really didn't see that as a career or an area of a new frontier for research. But once I was introduced, started to learn about essential elements and how to apply them to increase the health and vigor of plants and quality and yield, that made it something that I could spend some time and dedicate my career to.
What were some of the new discoveries that you made?
Well, everything was a discovery at first. Just the essential elements. Oh my goodness, you can grow without soil. But some of the bigger ones, back in 2001, okay, so I was into my career already. I'd been doing a lot of work, professional development workshops with agriculture teachers all over the country. But I took a trip. I was invited to go to the Netherlands for a trip to visit the schools in the Netherlands, see what they were doing, how they were teaching, which was very interesting, but also to see some of the latest developments they had on increasing the plant's resistance to powdery mildew molds. In the year 2000, the Dutch made all synthetic fungicides illegal on food crops because at that time, at least, probably today too, every single synthetic fungicide had at least the potential for negative side effects for human beings. So they started experimenting with organic biostimulants that were coming out of Germany. And they said, oh, these have some good things, not just for pollution control and improving crops, but on disease resistance. So I was able to interview a Dutch grower who was doing the trials for the Dutch government on organic biostimulants as an alternative to fungicides. I went in there, I got to interview the grower directly on television, back and forth, and record it. They went from losing 40% of the crop to pests and diseases to losing zero. Wow. They got a 10% increase in yield over any past year, and they were first in the line for quality, for sugar content in the fruit at the greenery. I said, wow, I got to interview the German scientists even that developed the product. What's in this? How does it work? That's what I always ask. What's in it? How does it work? Yeah. This is fantastic. We need this in the United States. They wouldn't tell me. They said, this is proprietary. It took us 10 years of research, blah, 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 blah. We can't just give it away. But I saw it with my own eyes. I knew there was an answer there. I knew it was organic too. Eco 1, highest level of organic certification. I went back home to the US, made it my mission to try to solve the mystery. It probably took me 3, maybe even 4 years of intense research, just looking for clues.
Mm-hmm.
And finally, the pieces came together. I was sent a organic biostimulant product from a vitamin manufacturer out east. They said, we've been seeing some interesting results. Would you try this? And I added it. It was an amino acid blend with kelp. And the first thing I noticed was in my hard water at home, no more lime scale.
Mm.
You know, every time I added my pH down, phosphoric acid, I could see calcium phosphate forming and falling out of solution. It was gone. It wasn't there. Where did all the calcium go? Into the plant. Then I started to put two and two together. And I found out, and so narrowed my search, that two of the amino acids, glutamic acid and glycine, literally stimulate root cells to open calcium ion channels.
Okay.
So instead of one ion at a time of calcium going into the root, 1,000 calcium ions went into the roots, taken up in the transpiration stream. It reacted, formed the calcium pectate, the glue that glues the cell walls together. So I said, I think I'm onto it. I think I've got it. That was a big clue. So I looked a little further. When a powdery mildew spore lands on a leaf, it doesn't germinate in the surface water. You can rinse it off, but it sends down a tube to get to the water in the interstitial space. It gets established in the tissue, then it sporulates and spread. Well, instead of water in the interstitial space with all that extra calcium uptake, it was calcium pectate. So by the time that germination tube could get to the water, it dried up and died. Powdery mildew. So it didn't kill powdery mildew. It prevented the powdery mildew from getting established and then spreading. That was a huge advance for me. I started applying that technology in different ways, in different fertilizers that I was developing.
Okay.
So that was probably the biggest advance. I also found out that the extra calcium that doesn't get locked up in the cell walls, the plant pumps it into the vacuole storage in the cell. And then if there's a little bit of fungus, the plant senses the chitin in the cell wall of the fungus, sends a signal molecule to the vacuole, opens up calcium ion channels inside the cell. And thousands or millions of calcium ions flow into the cell, start an oxidative burst. And that's the plant's first line of defense against fungus. It's natural resistance. So it was great. Started applying that in many different ways to improve not only plants' natural resistance, but if you have a stronger vascular system, stems and leaves from the calcium, the plant takes up and distributes water and all of the other essential elements. And that has a chain reaction of effects. So it was exciting. It was exciting just to solve that. It took a long time to finally get that one clue that made everything make sense.
Well, so you're working on it for 3-4 years, multiple years. How, once you had that aha moment or that discovery, how did you make the decision to share that information compared to the counterpart in Germany where that was just like, hey, I've got so much time invested, this is now my IP?
Well, part of it's just my philosophy of life, I guess. I'm not going to sell or share recipes from a company that I'm working for,
Yeah.
It's their recipe. But I feel like science should be freely shared. Now, I wasn't in a research facility at a university, so I didn't have to, but I started to teach classes, and I thought, I'm going to provide this information so that other growers can benefit. I benefit from the inventions and discoveries of others. Isn't it right for others to benefit from my discoveries as well? And so I did it. I like to freely share in general. And I think it comes back because I want people to use this and build on this in future generations. This isn't the whole story. This is one piece. It's an important piece, but we have to make some changes in the way we grow food and the way we grow cannabis in the future. if it's going to be sustainable. We can't just keep developing new poisons to spray on our plants. So I just felt it's important to share the discoveries, and hopefully the viewers out there will gain from that. We'll start to apply it, maybe take some of my classes, and then go out there and make the world a better place.
Well, talking about your classes, they are very sought after. And it seems that there are only rave reviews following people that take your courses. What is it about your 8 and 12-week courses, in particular your master class courses, that seem to really resonate with the cannabis community?
I think what it is that I'm not trying to overcomplicate it. I really try to explain things in an easy to understand way. And more importantly, it's not just knowing, what photosynthesis is, but it's being able to find ways to improve the efficiency of photosynthesis, to be able to use what they learn, apply it so that they can grow better plants. And I think that's the bottom line, because even the people out there that have been growing for years, longer than me, they're experts, they're master growers, and they're taking my classes. I think really they should be teaching me. And believe me, I will learn from any of you out there that has something to teach me. But what I find out is that the veterans even say, oh, now I know why that works. When I've done this and this and this, why I've seen an improvement. And that helps them to make better decisions in the future. And those that have remember, I was working with schools at the beginning. I was teaching even 5th graders about introduction to hydroponics. So I had to find ways to simplify the concepts, but not to water them down. Okay. And I think that's what my students enjoy and appreciate about the classes. Is I don't get too technical. I do throw in some vocabulary. You learn, because that's how I learned. Yeah. If I go to a book when I'm looking for clues and I learn a new technical word, I go into Google, like everybody else in the world, and I type in plant physiology, and then whatever the keyword is. And then I get a whole bunch of articles, usually a little more technical, to look at, and I can go through those, scan through them until I find something interesting. I read the conclusions. Then if I really get interested, I go into materials and methods and see exactly how the experiments were done. So, so I do want to give some technical words too, and some vocabulary, so that they can understand the science when they read it someplace else. Otherwise, they would just be like over their heads.
Is that part of the disconnect in the legacy cannabis grower market, that they've sort of just been figuring out how to do it on their own, and they haven't come up with necessarily a formal scientific background? Is that why there's a disconnect sort of going from the legacy market to the new professional market or legal market?
Yeah, I think it's part of it. We were forced in the cannabis industry to learn by trial and error, and just to find out what works. There wasn't data. You couldn't go to the university and say, oh, what's the ideal level of phosphorus for cannabis? What's the ideal level of nitrogen? It wasn't published. So you'd have to kind of look at what other similar plants or other plants and then do this, but it takes forever. And trial and error is not the way to do a commercial professional grow. That's hobbyist in their basement, that's fine, trial and error. I'll try this, I'll try that. But you really need to be able to make decisions based on data driven, if you're going to be successful in commercial cannabis production. And there's no commercial data to rely on. You kind of have to start with someone that has some good basic knowledge and being able to build on that.
Are we starting to create a good base to build the industry upon?
I think so. I think we are. The hardest part is unlearning some of the myths that we were taught along the way. But once you do, we can do it. And also we need to learn how to be more efficient in the way we're growing. When it was really a high value crop, super high value, I mean, doesn't matter how much you spent, you're going to get a return on investment. Now it's not the same way. Now you have to get a little lean and mean. You have to be more efficient with your fertilizer, with your energy budget. You need to be able to bring out the characteristics you're looking for. You need to be able to save a little bit on labor. So, yeah. But I'll tell you what I've seen in the industry is that a lot of times they get the legacy grower and they try to teach them the new technologies, the new computer technologies and so forth, computer controls. I think that was a little bit of a mistake. I think it would have been better to take some of the commercial, say, tomato growers and cucumber growers and pepper growers that were growing 12-foot pepper plants loaded with pepper and taught them about cannabis. I think that would have been less of a learning curve in the early days. But it's starting to come together.
Okay. What are those myths? What are those myths that need unlearning?
Oh, well, first one, I remember I was developing fertilizers for years in research and development. The one is too much nitrogen.
Yeah.
If a little is good, then twice as much is twice as good with fertilizer. Well, let's just keep raising the amount of fertilizer. Plants will take what they like and leave the rest. Generally speaking, that's true, but not always. Nitrogen is a luxury element. It's not, no rocks have nitrogen in them, no minerals. It comes from recycling of organic matter or from nitrogen fixation from beneficial bacteria. Okay, so because it's been a limiting factor for plants for so long, the plant gets a little bit of nitrogen, it'll assimilate it, whether it needs it or not. You give it some more, I got some, I better assimilate that too. Store it for later. Give it some more, I'll assimilate that too. So it's really easy to overdo it. And if you do, then you get big cells with thin cell walls because of the nitrogen, big top growth, but restricted root growth, and the plant becomes more susceptible to pests and disease. And it can have effect downstream on quality and yield. If you super overdo it with nitrogen, you can delay or even prevent flowering. Now, usually you don't go that far. But in the industry, though, when I was developing fertilizers, I was always being pushed to increase the nitrogen levels in my formulas. And I said, well, they don't need that much. Yeah, but, give it the growers, they want to see a quick response. So you give it more nitrogen. Oh, look how fast my plants are growing. I said, yeah, but that's not good for the plant. And it's not going to be good in the end for yield. Yeah, but, I said, well, I'm not even going to do it then. I just finally put my foot down. I'm not going to put in excess nitrogen in my formula. And it's, well, we didn't mean that, So I said, okay, I'll find a compromise. But I think that's one. Too much nitrogen is a big mistake. And then they have to go through all these other things to flush and do everything just to get rid of the excess nitrogen. Mm-hmm. If it's already built up in the tissue, it can contribute to the off flavors later on.
Yeah.
So no, that's one big one. The other myth is excess phosphorus. Yeah, they need phosphorus during flowering. I mean, that is important, but they don't need 200 parts per million of phosphorus. I mean, they don't. There's a certain point, and it's not even very high. You just get to 30 parts per million, you're probably starting to plateau on the response of the plant. Maybe 60. I would go 59 parts per million just for the optimal yield without overdoing it. But you get a phosphorus toxicity, it'll show up as a zinc deficiency. And that can affect the growth hormones in the plant. So don't overdo with that. And also, I think that excess phosphorus is stored up, and then it starts to burn like road flares.
Yeah.
So if you want quality, you don't overdo it. You want to create healthy stress, but you don't want to cause a toxicity of even one element. So those are two big ones.
How would you describe the state of growing cannabis in the United States, and beyond that, the state of how we grow our food in the United States?
Well, let's see. I'm not sure how to answer that. I know that we're still behind the world in hydroponics, which is in general, and that's a very good way because of precise control and management of the root zone. But the biggest thing I don't like about the United States, even in hydroponics, is most systems are drained to waste. In other words, that the water and nutrients go by the roots once, then down the drain, and that's not good for the environment. It's not, overdoing in soil as well, over fertilizing. Where if in the Netherlands, the national standard is zero runoff. They're even capturing rainwater from the roof, and they're cleaning it with different ways, even with biofilters. They're 20 years ahead of us in that, and you could cut your fertilizer costs in half just by properly recycling, recirculating it, and protect the environment at the same time. So that's one thing I feel we're wasteful in this country. We say, oh, the cost of fertilizer is not that much, so just do it. But sooner or later, you're going to pay the price.
I was going to say,
The outdoor growers, even in the farms, they've been using 5 times more fertilizer than plants need. Here in Michigan, the soils are saturated with phosphorus because of the overuse. So even if you added manure to the land, one good rain, that phosphorus would run off and go into the lakes and streams, causes algae blooms. We need to be better managers of the inputs. And one way to do that is by having recirculating systems and also using plant growth promoting rhizobacteria, mycorrhizal fungi outside, so they can unlock the phosphorus that's locked up in the soil and make it available to the plant. Where in other countries, they're already doing that. Like I said, zero runoff is the national standard in the Netherlands. They even measure how much water is being taken up from the well, and they're required to replace it during the raining season, where they get some fines. And you think, oh, how can anyone make any money when they have to spend all that on protecting the environment? Guess what? They are so efficient now that they can grow they can grow tomatoes at below growers' cost here in the United States, below the cost of growing. And that is going to apply not just to tomatoes, we're going to just take that down the road to cannabis and other crops. It's just too expensive.
So what's the shoe that has to drop first? Is it that cost has to be more of a pressure? Does there have to be more regulatory pressure in order to, sort of fix this waste stream?
I would like to say no, but I think the reality is that people aren't going to change until they have to. Oh yeah, if you have just spray pesticides, that's the way we always did it. You have a disease, so just spray. But having to think of it, really work with biologists to find new solutions that are more sustainable and more environmentally friendly. Why do that if I can just spray some chemical on there and solve the problem like that? So I think that some of the environmental regulations are going to be part of it. At the same time, like I said, I want to say no because some of the regulators go overboard.
Oh yeah.
And if I had to just work with regulators for a job and you were going to double my salary, I would say no way. I'd rather work 2 years with peace of mind than 1 year pounding my head against the wall, because there's some things I found working with regulators in the past that it's hard. You can't really reason with them when you even if you find something that works better.
Mm-hmm. What do you think? Does cannabis have the opportunity to push this movement forward? Just because cannabis seems to, and I've talked to some growers in Michigan in particular that have organic grows and try to have best practices when it comes to waste and the energy inputs. Does cannabis have an opportunity to influence other industries in terms of best practices?
I think so. I think it does because there's more. We've done more with indoor growing, where we can control all of the variables. And because of that, we can make new discoveries, and those discoveries can be applied to other crops. So yeah,
Okay.
there's a great opportunity.
Well, and I've seen there have been a number of indoor grows that have shut down, not in cannabis, but in other industries that just haven't been sustainable enough. Is it just that we haven't given indoor growing enough time, or is it that the profitability isn't there versus more of traditional methods right now?
When you're growing under lights, it's expensive. Light is the limiting factor. Yes, we've made improvements in lighting technology with LEDs. Um, we've narrowed in our spectrums a little bit more efficiently as well. But still, there's no substitute for sun. The plants have evolved under sunlight. So, trying to grow tropical fruit indoors under lights is kind of challenging, to say the least. And you have a lot going against you already. And then it becomes more labor intensive and so forth. So it's not easy. Now, greenhouse growing. Now, if you'd like, just go to the Netherlands sometime, and if they'll show you what they're doing. They're learning how to decrease the energy budget from year to year, and we can do it too. Here's something just from my discoveries. One of the things I found when we got more calcium uptake, talked about that earlier,
Mm-hmm.
was the Brix goes up, the sugar content in the sap. And when that happens, the freezing point goes down. So
Okay.
if you can control the root zone and lower, even in the winter when you have lower temperatures, you can the plant will be more resistant to frost. When I was doing my first experiments outdoors with these amino acid blends, I went through 3 hard frosts and didn't lose a single plant,
Wow.
which was pretty darn cool. Now in Ohio, under glass, the growers, the lettuce growers, they will lose money in the winter on purpose. They'll do it because the cost of heating is so high in the greenhouse. If they could lower that air temperature down to just above freezing, just heat the root zone temperature, they could get no reduction in cycle times and keep a higher and make more profit. So there's ways to apply this with, well, let me just put it this way. If you work with nature, you understand what's going on with nature, there's going to be beneficial side effects that you never anticipated. If you work against nature, sooner or later, there's going to be negative side effects to the environment or to even to us and people as we develop cancers and other diseases. So, yeah, what we can learn for cannabis, because we have the budget to make it work, we can apply to other crops.
So for the lettuce growers in Ohio, is it that they just don't know how to do it better? Is it a lack of education, a lack of training?
It is. It's part of its lack of training. Back when I started, we didn't even have hydroponic research greenhouses. In Michigan State University, where I live in Michigan, they didn't have one. Ohio State University, 0. University of Wisconsin, 0. They had no idea even about how to use hydroponics, let alone the things that we've been learning since in the last 30 years. So, yet they were doing some good organics programs, more power to them. Very important. They were doing a lot with organics too. Oh, more power to them. I love it. That's what you need to do. We need that. But that's not the whole story. We need to convert unfertile land into fertile land. And we need to do it in a responsible way. So there was no education. The growers didn't know what to do. I went to, when I was making that very first video back in 1995, Introduction to Hydroponics, I did an interview with a commercial grower in northern Michigan. They were growing tomatoes, they were growing lettuce and herbs. And they were having problems with zinc deficiency. They said, well, we sent our nutrient sample to Ohio State, and they said there was plenty of zinc. But we're losing 2 or 3 sets of tomatoes early in the season when the prices are highest. What's going on? Of course, I'm there just to learn. This is my very first video I'm making. So, well, let me go and try to see if I can find out. So I went back and I got Resch's book on hydroponic food production, which was one of the books I was using for reference. In the first chapter, it talked about phosphorus toxicity showing up as a zinc deficiency. And I thought, well, and then I also took it one step further, and this is 30 years ago. Oh, phosphorus is temperature dependent. If the temperatures are too cold for at the root zone, plants won't take out phosphorus. So what was happening is they were adding the nutrients, and the plant wasn't taking up phosphorus. It was building up in the tank. It was there. And then all of a sudden, you get 3 or 4, 4 or 5 warm days in a row in March, the plant starts pulling all that phosphorus up, zinc deficiency. I mean, but that was in the first chapter
I was going
of
to
a
say,
book on hydroponics. And those farmers never got to take that class.
I was going to say, did you just go back to them and say, it's like in the 3rd page?
Yeah. I went back. I went back to them. And at first, I said, when I went back, I said, I was doing a little research on, and I found out. He goes, well, Ohio State does research. I said, well, obviously not this research. And then I just reasoned with him. I said, well, if there's areas of the root, the greenhouse is cooler, you won't see that much phosphorus uptake. You won't have the deficiency. What are you seeing? And they start talking back and forth. Yeah, that's what we're seeing. Okay. I said, well, the real answer, though, is to warm up your nutrient solution. Put this little submersible heater in there that you'd have in an aquarium down in your reservoir. This was ice cold water. That's really cold water up in northern Michigan. And it wasn't heated. It was only heated once it was up in the crop. So, there's some of these solutions are very simple if you have a little bit of knowledge. And I don't blame the farmer. They couldn't take even one single class on hydroponic vegetable production. It wasn't available. So they have to learn by trial and error.
Right. So
in this case, it was error.
Other than yourself, are there any universities or other institutions that are doing it right nowadays?
Oh yeah, there's some. University of Arizona. I visited their facility out there. I like what they're doing with computer environmentally controlled agriculture, with hydroponics. But when I visited there, they were still doing drain to waste. And of course, they hadn't gone to the next level with the biostimulants, learning some of the secrets of nature. They weren't doing that work. Let's see, where else? Cornell was good. I don't know if they're still doing their program, but I attended some good workshops from professors at Cornell. Okay. I learned a few things about the root zone temperature. I learned that from them. And I'll just say what I learned from them. Cornell, they were doing NFT, where the nutrients are flowing over the roots and then being captured and recirculated. In Minnesota, in the greenhouses. They were growing in the winter, and you know how cold it gets in Minnesota in the winter, even if you've never been there. Just look at the weather map. What they found out, though, is if they kept the root zone temperature at 75 degrees, that they could lower that temperature down and still be able to get the cycle times, which is something I mentioned. I learned that from Cornell, and other growers applied it. So you can save energy costs instead of spending a fortune to try to heat all the air in the greenhouse, when they have an R factor of 15, in a greenhouse. Well, just heat the roots instead and let the air temperature fluctuate. The same thing in the heat too. If you cool the temperature of the root zone, keep it between, say, 68 and 75 degrees, that the plant can handle extremes in temperature more efficiently.
When did you decide to stay more on the educational side of the industry, the cannabis industry, or did you ever consider getting into product commercialization?
Oh, I did a lot of commercialization. That's how I paid the bills. was a research for hydrodynamics internet. It's the company that makes Clonex. I developed some specific fertilizers from other plants. That was great. The discoveries I made there using amino acids, by the way, as part of the formula. I was also director of research for NPK Industries out in Oregon for years.
Mhm.
So I spent many years in my career working with product development, but education was always a part of it. I would do night classes
Okay.
and for growers even back then.
Okay.
I came that close to being an adjunct professor for Michigan State University. They finally realized they had a technology gap with
Okay.
hydroponics.
So,
And so I came close, but it didn't go through in the end.
okay. Did you, and you broke up a little bit when you were talking about product commercialization. What are the products that you've brought to market that you're the most proud of?
Well, the my first one and the one I'm most proud of was a product called Mother Plant, and it was specifically formulated for stock plants for mothers.
Mm.
And in that, I lowered the nitrogen. Not only lowered it to the high end of sufficiency, I lowered it to the low end of sufficiency instead of the high end. I did a 1-to-1 potassium to nitrogen ratio because excess potassium will tend to translocate the nitrates to the shoots to get stretching. And then I added the amino acids and kelp, humic and fulvic acids, little B vitamin blends, just to aid with the uptake of nutrients. So I got tighter notes and more stored energy, small cells, thicker cell walls, more resistant to disease, and more stored carbohydrates. And then from there, it was more applying different products like kelp extracts, humic acids, and some of the others, humic and fulvic, in a way to be able to help draw the nutrients into the tissue. And I did develop some base nutrients as well when I was at NPK Industries for commercial growers, some
Okay.
base nutrients. So yeah, I've done a few along the way.
What were some of those experiences that you had with regulators that just have you keeping them at arm's length and certainly not taking that professional track?
Oh boy. I'll tell you just two that come to mind. First one was back in the old days, in the old days, we import when I was at hydrodynamics, we were importing a product and labeling it, and it was called SMC. It stood for spider mite control. And
Hmm.
it was just basically a light horticultural oil. You could put it on your salad and eat it. But the way it worked, when it hit the mite, it would block the breathing pores, and it would kill the mites. The oil would also desiccate the eggs. So it was a good, natural, very benign way to fight spider mites. But on the label, it had a picture of a sight of a gun with a spider mite in it.
Okay.
And the regulator said, "Oh, you're making a claim from that picture. You're claiming this as a miticide. And if you claim it as a miticide, it has to go through 5 years of all this different science to prove that it's harmless." Say, prove that it's harmless is generally regarded as safe. Yeah, it's generally regarded as safe unless you make a claim. And then it's not. You have to prove it's safe. So what they did, I'm looking around, but I don't think they even do that product anymore. But they just took the picture of the spider mite off, put a picture of a drop of water, and they just put on there a clean leaf is a healthy leaf. And so there's a leaf wash. And then the EPA can look at that and say, oh, the oil is generally regarded as safe. They have to prove it's unsafe, which they can't because it's
Okay.
not. I mean, because it's not unsafe. So that's just one example. Another one, a little more technical, we had a humic acid product that usually doesn't work very well at lower EC or lower pH, and they did a process with it, sulfonating it, so that it would stay soluble in the water. Well, you go to the regulators, would came back and said, well, there's not as much humic acid in there as you claim.
Mm.
There's not. I mean, we put it in, we know it's there. They said, well, what they did is they would acidify the product, and whatever fell out of solution, they'd measure. And that's how much humic acid. They said, well, we have a process with this where it stays soluble and it won't fall out of solution as much under the hot. So there's really more than what we say. They said, well, this is the way we test. Well, what if you suggested a different way of testing? No, this is the way we do it. And it's an even playing field for everyone. So, but it's not an even playing field because we've made an improvement on the solubility of the product. Did it matter? No. Here's the last one, fulvic acid. To this day, I don't even know if you can put fulvic acid on a label. And we know it has, I mean, all kinds of scientific literature is proven to aid with the uptake of nutrients and iron and other important things. But because the regulators couldn't define fulvic acid so that they could define it and then test for it, they weren't even allowed to put the word fulvic acid on the label. So the fulvic acid products, they just called it low molecular weight humic acid. But you see what I'm saying? It doesn't. I'm glad the regulators are there. We need them to protect ourselves from unscrupulous manufacturers. But there's a point where the regulators start to fall behind the science and they're behind the discoveries, and they don't update fast enough. So a lot of the new things that we could use, they reduce the amino acids, reduce the powdery mildew to 0. I couldn't even tell people that on a label. Say, oh, you have a problem with powdery mildew? Here's how to improve the plant's natural resistance with something that's organic, that the plant uses anyway. I couldn't do that because I'd be making a claim. So that means there's a whole world in the United States of growers that are missing the benefits of some of the organic products that could be at their disposal, and they don't even know about it.
Well, I know that regulators are one of the reasons that a lot of people are apprehensive or push back when people kind of fight for federal legalization of cannabis. Do you think overall with federal legalization, there's going to be a net benefit to the industry? And how do you foresee that happening?
Yeah. There will be a net benefit, but it's going to be just like for any other crops. It's where the growing environment is friendly. Oregon, California, Washington, they can grow a lot of really high quality cannabis outdoors. They grow way more than they need. Supply and demand. What happens? Price starts going down because they can't export it. I mean, the economics, the areas that have a surplus of a product, send it to some place where there's a deficiency of the product. And and the prices they balance themselves out. If we had legalization, we could do interstate commerce. So there'd be benefits there. And we can ship overseas. That's what's going on in Canada. In Canada, they can literally, because it's federally legal, they could import from Colombia. They could process it and then ship to Germany or to Poland. And so even though they have lower population in Canada, the whole country, lower than the population of California, they can still be viable because of an import-export market. Now, that means things are going to level out again, too. When that happens, it's not going to be a boom for everybody. The places that, Florida grows oranges. We're not ever going to grow oranges in hydroponics under lights. So we're going to be bringing those in. Same thing with the cannabis. We can still compete, but I think that the areas that have the environment, have the sunshine, have the labor costs, they're going to always have an advantage under federal legalization.
Okay. For people that are interested in your masterclass, What level are these people typically going into the class, and what can they expect after taking the course?
Okay, I try to do something for all levels, even beginners, but I would say intermediate to advanced would be the most of the people in the class. They'll get the most out of it, you know. But then again, I have some people that are growing in soil and growing in organics, and I have classes for them. Organic biostimulants. I have a couple of classes on integrated pest management. I have classes on organic biostimulants and even soil microbiology. So there's lots of stuff for them, but at the same time, they're getting exposed to hydroponics and precision fertilizer management, um, spoon feeding, some of the strategies where you give the plant exactly what it needs when it needs it, ways to be able to measure and see what nutrients your plants are actually taking up. And that applies to soil or hydroponics.
Mm.
So, and I have one class that's my old introduction to hydroponics class. That's for beginners that have never done it before. And in that 1 45-minute class, they can learn everything they need to know to be successful. Not everything they need to know to reach the genetic potential of the plant, but enough to do better than they would ever have dreamed. So yeah, but I think it's really the intermediate hobbyist to commercial grower.
In your opinion, what are ideal growing conditions for cannabis?
Ideal growing conditions. Um, let's see here. About you want to have for indoors temperature and humidity. You want to keep your VPD, vapor pressure deficit, somewhere around 1.0 to 1.3. I would say would be ideal, especially during flowering. Create a little healthy stress. Plants under stress, it's going to make molecules, antioxidants to protect itself from stress. Those are the colors and aromas and flavors. Um, a good temperature range with CO2, 84, 85 degrees with carbon dioxide supplementation. Without CO2 supplementation, maybe more like 78 to 82 degrees. With CO2 supplementation, you can raise the temperature 5 degrees without the plant going into stress or photorespiration. Let's see what else. You want to have good control of your root zone dryback, as well as the pH and EC. I like low to medium EC for vegetative growth, keep the stress off the plant, and then medium to high EC for fruiting and flowering to add some stress for the plant to get more quality. Light intensity, anything over 950 micromoles would be good. I don't think we really need to go 1400 micromoles. You could, but you start getting up into that really, really high light intensity, sometimes the plant's not using it all. Mm. But finding the limiting factor, though, that's the thing. It's not so much add more light or raise your temperature. You can do all that, but balance it. I worked with one grower in Oregon. He had me come in as a consultant because he had one room that was underperforming. I went in there. I looked at some of the signs of nutrient deficiency. I found some signs. Then I did a side-by-side test. I took a leaf with that symptoms, another leaf with no symptoms. I ran them side by side in my lab. I had a ICP-OS spectrometer at the time, and I got to read all of the elements. The one with the symptoms was 1/3 the manganese of the one that had no symptoms. So I said, "Oh, this shouldn't be a deficiency, but it's not as much as what it needs." So I said, "Okay, we got to fix the manganese. Why is there a manganese problem?" So I looked at their light. They went from the vegetative growth stage with a lot of blue into the fruiting and flowering with a lot of red. And it was just that 2-week transition period between the two that they were getting the problems. So I said, okay, let's add 30% more blue then to your flower room for that period. And the other thing, they went from with CO2. They went from the low CO2 and jumped up immediately to the high CO2. Well, in that case, the plants start to close the stomata until they adapt to take in the CO2 because they're not used to having that much. Also, when you took away that blue light, the blue stimulates the stomata to open. So we took away the stimulus to open and we increased the stimulus to close. So it wasn't able to take up enough nutrients. Okay, so we made those, and then we needed to fix the manganese. So I helped them make a manganese amino acid chelate, do a foliar spray at that stage. Long story short, that went from their worst room, it became their best room ever immediately, just by making small changes, right? Yeah. And at that time, they were in the Oregon Growers Classic. All the top growers had the same genetics to work with. And when they made that change to the manganese is a limiting factor for the production of the terpenes and also for the cannabinoids, manganese and magnesium both. Anyway, when they got the manganese up to optimal levels for the whole room, not just fixing it at the low levels, they ended up winning first place in the state of Oregon for terpenes, first place in the state of Oregon for THC. So, yeah, we want to, it's not so much, this is the ideal environment. This is a good environment, but finding whatever the limiting factor is and correcting that. And you can see a huge increase significant increase in response.
Do you have a personal connection to the plant?
Yeah, I do. I love it. I mean, how could you not? I don't know. I mean, I've had a personal connection even when I was doing, in the old days when it was illegal, wasn't growing at that time. I was doing fruits and vegetables. I had a connection to my plants then. And I had gourmet quality herbs, fruit on the vine, full spectrum light. I mean, it was good for the soul, good for the body, right? And you could eat the tomatoes like an apple. They were so meaty and full of sugar. But then when I started experimenting with cannabis, once it was legal, I had my card. I said, wow, there is a lot to this. No, the people out there that are smokers that don't grow, they'll never know how magnificent that plant is. All of the different aromas, the terpene profile while it's growing and maturing, just watching the flowers develop. I mean, it's you can't help but to fall in love with that particular plant. And so I have a place in my heart for that too. So I like all of it. I mean, I like to grow gourmet quality basil for my seafood fettuccine Alfredo, and I like picking tomatoes off the vine in the middle of the winter. But I also like to grow the best of the best of quality and yield. And I go, of course, more for quality than yield. It's for personal use. Like one plant is going to give more than I need. But if I can grow something that has some unique characteristics, some unique genetics, and I can help the plant express those genetics, I feel like I'm in a relationship with the plant and not just growing it.
So when it comes to growing something with unique characteristics, when did you start growing the chops?
I don't remember. It was probably early in my career. It was just one of those days where I used up the last of my shaving lotion. Mm-hmm. I just had a little bit left, just a little dab. I said, oh, well, what am I going to do? So I just put some in the middle and just did that. And I went, oh, that's pretty cool. Let's leave it like that, see what it looks like. So I've done it ever since. And then after a while, people got to know me by the chops. They come into the store or something. Yeah, I heard this from Chops. Or I heard this from the Wolverine, whatever thing that they did. But it was always recognized as that. Okay, well, it'll just be my, whatever you want to call it, my signature.
Oh, definitely. Definitely very identifiable. And I thank you very much for being.
You've got some manly facial hair there too. Actually, very good.
Thank you. It was kind of similar, right? Where you start growing it, and you're like, well, I don't know, we'll see if it grows, and then it does, and you're like, well, I kind of like it now.
Yeah, right. Yeah. I don't know if I shaved them off. I don't know if people even recognize me.
Yeah, that's where I'm at now. I used to shave in the summer. and now I have small kids, and I don't want them to not recognize me.
Right.
But sorry, thank you very much for being generous with your time. And I just, before we get out of here, I wanted to make sure, is there anything else that you want to make sure the Cannabis Equipment News audience either knows about yourself, your classes, or anything in general about Harley Smith Hydroponics?
Yeah, I think if I have a website now that I'm retired, I'm still doing consulting. If you want to do some one-on-one stuff, I'll be out there. I'm available. But if you go to hydroharley.com, there are a lot of free resources there. I have a lot of magazine articles I've written that are on there too, at least the text. I used to write for Maximum Yield magazine. And I have all the information for upcoming classes and how to register and how to attend. So go to hydroharley.com and see what's up.
Well, Harley, thank you very much for taking the time. And I mean, so what does it feel like knowing that you're like a seminal educator, like for an entire industry?
Feels good. It feels really good. And I get fan mail all the time, and that makes me feel good. I enjoy that, to know people respect me and they appreciate the work I've done. But really, it's not about me. It's about the plant, about the plants. Let's put it that way. If people apply what they learned and come to me and say, Harley, I took one of your classes, or I saw something on YouTube and I did it and I'm getting the best results ever, that is the way to thank me more than anything else. And that makes me feel like it's all been worth it. All those years of R&D and teaching, it's worth it. If the word gets out to enough people, we need to get to more people, and even in commercial crop production, and they can apply it, because that we can feed the world in an environmentally responsible way and create high quality medicines that we can all be proud of. So, yes, I feel good about being known, but I feel even better when I've learned that they're applying what they've learned.
Well, right? You've legitimately made the world a better place. And thank you.
Hey, what else can I do? That's a good use of lifetime.
Very much so, Harley. And thank you again. Well, before we get out of here, please make sure to like, share, and subscribe to the podcast. You can also help us out a lot by leaving the podcast a positive review on whatever platform you use. If you want to email the podcast, you can reach me at david@cannabisequipmentnews.com with email the podcast in the subject line. You can also subscribe to our daily newsletter. Make sure you get it delivered to your inbox first. For Harley Smith, research and education professional with more than about 30 years of experience, and with Harley Smith Hydroponics, I'm David Manti, and this is the Cannabis Equipment News Podcast, and we'll see you next week.
Thank you for listening to the Cannabis Equipment News Podcast.